Hey guys, welcome back to the LearnAP Calc series here at LearnAP. In this video, we're going to go over motion along parametrically defined curves and some practice problems. Now note that this is for BC only. So if you're in AB, you don't need to worry about this, but if you are in BC, this will be covered on the BC test. So you do need to know this. As usual, if you have questions, you can ask in our weekly live streams. Those are every Sunday from 4 to 5 p.m. Eastern, or you can also just leave a comment and I'll sort of get back to you on your question. Other than that, we'll get started. Alright, so let's talk about the basics of parametrically defined particle problems. Now, problems like these will give a position as a parametrically defined function of time. So our position is equal to x of t comma y of t. So in part 1 we had horizontal motion, that we were only moving along a horizontal line. Well, in these we might be moving along, say, a curve. Now our velocity vector is given obviously by dy dt comma dx dt. And I've given it these sort of strange looking I don't know what you'd call these brackets, but that's basically saying that this is a vector. What a vector is, it means that not only do we have, say, a coordinate, but it's also pointing in a certain direction. However, this isn't very important for BC calculus. Just know that when you write your answer for velocity in a problem like this, you should sort of use these brackets, like so. Now, our speed is the magnitude of velocity, meaning that this is dy dt squared plus dx dt squared, and all of that taken as the square root. And our acceleration vector is just, again, the second derivative here. Alright, so let's do a quick example problem. A particle moves along a line where its x position is given by x of t equals sine t, and its y position is given by y of t equals cosine t. What is the position at t equals 2? Find the acceleration vector at t equals 4, and how fast is the particle moving at t equals 5? Question mark. Okay, so here we want to basically figure out what is our position function. Well, our position function is the x position, comma, the y position. And these are given to us above. So I can write this out like so. Alright, so what is its position at t equals 2? Well, we can just plug in t equals 2. And we get the position at t equals 2 is, and then again I'm using my sort of brackets, sine of 2 comma cosine 2. Okay, find the acceleration vector at t equals 4. Now remember, my acceleration is the second derivative of position. So we have to take two derivatives here, so p prime of t is going to be like so, and p double prime of t looks like this. Alright, so to find the acceleration vector at t equals 4, we just plug in 4. And so my acceleration vector at t equals 4 is, and then again my brackets, sine of 4, negative sine of 4, comma negative cosine 4. Alright, and our last question was how fast is it moving at t equals 5? So I'll plug in 5 to here. Alright, but what we really want is speed. So we need to find the magnitude of this vector. So it's my first term squared, cosine squared of 5, plus this term squared, so sine squared 5, and all of that taken the square root. Now, you're all aware that cosine squared x plus sine squared x equals 1, and that's exactly what we have here, where x equals 5. So this is equal to the square root of 1, which just equals 1. And so that's sort of an important point here, that this parametric is a circle, and that in fact my velocity is going to stay constant, or not my velocity, my speed is going to stay constant no matter what time it is. And so that's just something to note here, that at t equals 5, the particle speed is 1. Okay, and so if you have any questions on this, be sure to leave a comment. Not sort of the easiest thing to get right away, but I figure the more practice, this comes sort of more natural. Alright, so that brings me to today's challenge problem. A particle moves along a line such that its position is given by p of t equals t comma t squared minus 1. What is the speed when t equals 1, and at what time t is the particle moving the slowest? The solution to this problem is on our website, LearnAPCalc, and I'll also put a direct link in the description. If you guys found this video helpful, please like and be sure to subscribe for future content. You can like us on Facebook and follow us on Twitter for updates about our new videos and live streams, which we do every Sunday from 4 to 5 p.m. Eastern for Calc. Leave a comment if you're still confused about anything, or also any other comments on the video in general. Other than that, I want to thank you guys for watching, and I will see you guys in the next video.